In the last video, we talked about the steps of the hypothesis test, right? What were the steps? The first step was writing the null and alternative hypothesis. Second step was finding the test value or the test statistic. So that test statistic formula depends on what you are testing for, okay? Step number 3 is finding the critical value and critical region, or find the p-value, okay? And the step number 4 is decision, write the conclusion or decision. That is all. There were 4 steps, okay? Now let us do all those hypothesis testing for real, okay? So the number 1 or section 8.2 is hypothesis testing for the mean when sigma is given, that is when the population standard deviation, this sigma is the notation for population standard deviation. When this is given, the test is called G test for a mean, okay? If you are testing hypothesis for a population mean, when sigma is given, we call G test for mean. If sigma is not given, we will call T test, okay? That's what we do. And there is a direct shortcut way using calculator too, but you need to know all these steps, okay? So these are the steps. Then step number 1 is finding the null and alternative hypothesis. Step 2 is finding the test value or test statistic. This is the formula. I stated that already in the last video. So this is x bar minus mu, sample mean minus the population mean, that is mu equals to whatever you use there. That's the value you will be using here, okay? And divided by sigma is the population standard deviation, and n is the sample size. N is the sample size. Okay, and step 3 is finding the critical value or critical region. We said it and then find the critical value and critical region, or we find out the p-value. So for the left tail test, this is what you use: inverse norm and then alpha comma 0 comma 1. For the right tail test, you use inverse norm because we need the left area, that's why you do 1 minus alpha and 0 comma 1. And for the two tail test, you find out alpha half and then you do inverse norm alpha half 0 1 and inverse norm 1 minus alpha half 0 1, because it is like for the left tail test, that is alpha is on the left, that's why you do alpha, you enter alpha in the inverse norm. For the right tail test, alpha is on the right but 1 minus alpha will be on the left, because you need to enter the left area of G alpha, area left of G alpha is the 1 minus alpha, that's why you enter that in your calculator. And for the two tail, you need to find out the alpha half, right? So you do, there is alpha half, there is another alpha half is here, and you need to enter alpha half to find out negative G alpha half. For the positive G alpha half, you just take the negative sign off and then write out G alpha half here, okay? So this is how you find out the critical region. But for the p-value method, you need to find out area left of the test value. See, this is the calculation syntax. Since you are finding the area, you need to use normal CDF, not the inverse norm. Normal CDF and area left of the test value. Normal CDF, area right of the test value. Normal 2 times normal CDF, area left of the test value or right of the test value, depending on where the test value falls. If the test value is positive, then you will be finding the 2 times normal CDF and the right area. And if the test value is negative, you find out the 2 times the area left of the test value, okay? And you write the decision. Okay, let us look at the example, then you will understand the things. All right, let us look at this. In Pennsylvania, the average IQ score is 101.5. This is what they believe in the whole state, okay? The variable is normally distributed and the population standard deviation is 15. In all these hypothesis tests of the mean problem, the variable must be normally distributed. And it is stated there. Even if it is not stated, you assume that, okay? A school superintendent claims that the students in a school district has an IQ score higher than the average. See, this is the claim. She claimed that it is higher. It does not have equal to sign here. So this must be the alternative hypothesis, is higher, okay, then 101.5. That is the alternative hypothesis. So, and to verify her claim, she selects a random sample of 30 students. that is the sample size, right? And find the mean, that is the x bar. Sample mean is 106.4, and you want to test the claim for alpha equals to 0.05. Use critical value method. So although it says the use critical value method, I can show you both method, okay? Both like p-value and the critical value method, no problem. And so let us do that. Let me first list what is given. So the average IQ, the population average is given. Mu equals to 101.5. Sigma is given. The population standard deviation is 15, right? And then what is that? It is right tail. Why? Because it says higher than, right? So mu greater than 101.5. That will be the alternative hypothesis, because it does not say, because it says higher than the average. Average is 101.5. Higher than meaning it is greater than, right? Greater than does not include equal to sign. That's why it is the alternative hypothesis. And then what else is given? Sample size n equals to 30 is given. And then x bar is given. Sample mean is given as 106.4. And alpha is given as 0.05. It is the right tail, right? Okay, let us write down all these things here then. So how do I do that? So basically you will be writing H0. What is H0 here? So H0 is mu equals to 101.5, and H1 is alternative hypothesis is mu is greater than 101.5. Okay, how do I find the test statistic? Is T, or denoted by G, is equals to x bar minus mu over sigma over root under n, right? Let us use calculator to find out that. So what you do is, let us clear what I have there. So x bar is how much? So let me plug in one more time, okay? Let me plug in the values there. You get x bar is 106.4 minus 101.5. That is mu divided by sigma is 15 divided by root under 30, right? That's what you get. Let me write the denominator thing with the parenthesis. So what I want to do there is, I want to use calculator. Let me enter those. Let me start with the parenthesis because there are two terms in the top. 106.4 minus 101.5. Close the parenthesis, divide, and then start the parenthesis again. 15 divided by square root of 30, right? And then let me go, just press the right button and then close the parenthesis. This is what we have, right? Let's hit enter. You got 1.79. So you got 1.79. Okay. Now I will show you both method, critical value method and the p-value method. Let us split that region. For the critical value method, this is right tail test, because it is this is also claim, right? Claim is the alternative hypothesis. It is right tailed. Okay, for the right tail test, so we have alpha equals to 0.05 and the right tail, meaning you will be shading the right side, right? Tail. So let me draw the G curve. So 0 is in the middle. Right tail means you will be shading on the right. What is the area? Alpha is 0.05, because you will be shading only on the right, because it is the right tail test, or it is one tail test. So you want to find out that G alpha. So to find out G alpha, you will be using inverse norm, right? Is inverse norm and left area left of G alpha. Inverse norm. What is the area left of G alpha? Is 0.95, right? 0.95, and then 0, 1. This is what you will be finding. So let us use calculator to find out that. Inverse norm is second verse. Go down for the inverse norm, hit enter. You will be entering 0.95. That is the area left of that. Mu is 0, sigma is 1. So let us paste it, hit enter. You get 1.64. So 1.64. All right. So this is the G alpha, that is that value. G alpha is 1.64. This is what we got. That value is 1.64. Now, if you are finding the p value, then what you do is let us draw that. Let us draw the normal curve, right? And then 0 is in the middle. So what, instead of finding the instead of setting that region, what we will be doing is we will mark that the test value, that is 1.79, right? Let me use different color for that. Let me write that. So 1.79 will be somewhere here, 1.79. So what we will do is we'll find out the area right of that. We'll find out that area. How much is that area? To find out the area, so the p value is area right of 1.79. So that's what you will be finding. So that will be normal CDF, but because for the area we'll do normal CDF. Normal CDF. Let me do that again. Normal CDF. What is the left bound is 1.79. Right bound is 10 to the 10, because we don't know how much is the right. It keeps going. That's why I pick a big number, and 0 and 1. If you do that, you will get the p value. Let me use calculator for that. For the normal CDF, second verse normal CDF is the number 2. You do that. So the left bound is 1.79, right? And the right bound is, upper bound is 10 to the 10. And then mu is 0, sigma is 1, and then you paste it, hit enter. You will get 0.0367. I can write 0.04, right? So this is 0.04. All right. Now, how do we make the decision? Again, in the test, you don't have to do both methods. You can do either this method or that method. But your calculator use p-value method. That's why I need you to, I want you to learn that method too. But the book focus on the critical value method. But the calculator, if you want to use calculator directly, this uses the p-value method. All right. Now, decision. How do we make the decision? So decision is made based on the methods. If you are using the critical value method, you look where that test value falls. Does the test value fall in the shaded region, or the test value do not fall in the shaded region? This boundary is 1.64. So the test value is 1.79. So it is bigger than 1.64. So it falls somewhere here. So the test value falls in the critical region. Okay. So if the test value falls in the critical region, we reject the null hypothesis. Meaning, so here, so this shaded region is also called critical region or rejection region. Okay, this is called critical region or rejection region. So what we do is, since T falls in the critical region, critical or rejection region, we reject H0. This is the critical value method. But in the p-value method, how do you write the decision? Is since p is less than alpha. What is alpha? Alpha is 0.05, right? So alpha is 0.05. P-value is less than alpha. If p-value is less than alpha, we reject H0. Now we write the conclusion. So both methods rejected the null hypothesis, right? So what we do now is we write the conclusion. Hence, there are enough evidence to support the claim. Because what was H0? H0 was, the average is 101.5, and H1 was greater than 101.5. See, you use the same number on the null and alternative hypothesis. This is critical, okay? This is very important. So don't use 106. Don't use the sample thing here. You always use the population thing here because it says mu. So mu equals to is the null hypothesis. You rejected that, meaning we support this one. We support that. There are enough evidence to support the claim that the average IQ is bigger then 101.5. That means the average IQ score in the school district is bigger than the state average. So we can support the claim, that school superintendent claim. Okay, so this is how you do. So you write H0 and H1, and then you do write down find out the test value, and you find out the critical value or the p value, and then you write the decision. Okay guys, so let us do another example. Actually let me do, if there is one with the p value method. So this example has a p value method, so let us do this one more example for the critical value method. Okay guys, so the second example on the hypothesis statement, which is example number 11, says that the Medical Rehabilitation Education Foundation reports that the average cost of rehabilitation for the stroke victims is 24,672. That is mu equals to 24,672. How do I know it is mu? It is not a sample mean. It is the for overall population. It doesn't say sample anywhere here. So it is the population mean. To see if the average cost of rehabilitation is different from, see, it is not less than or greater than, it is different from. So it must be two-tailed test. So to see if the average cost of rehabilitation is different at a particular hospital, a researcher selects a random sample of 35, n equals to 35 stroke victims at a hospital, and finds the average cost is 26,343. So x bar, because this is the sample average, right? It is 26,343. The standard deviation of the population is 3251. So it is sigma is the population standard deviation, 3251. So at alpha equals to 0.01, so alpha is given at 0.01. Can it be concluded that the average cost of stroke rehabilitation at a particular hospital is different from means not equal to, right? Different from that, use critical value method. Okay, all right, so I'll use critical value method only on this. Okay, so what is H0? H0 is mu equals to 24,672. What is H1? This is mu different from 24,672. That's what the question says. So this is two-tailed test, right? So two-tailed test, two-tailed. And so what is there a claim? The medical this reports that the average cost of rehabilitation is this. To see if the average cost is different from that. Okay, this is the claim, right? Actually, if you look at the question, you see that the rehabilitation foundation, it reported, basically it is claimed that the average cost is 24,672, right? But the researchers say, it may not be true. And then it collected the sample of 35 stroke patients, and then the average cost was 26,343. Now you want to test whether that claim is true or false. Okay. Now let us find out the test statistic. How do I find out that? Is T or G? Because the sigma is given. That's what we call G test. Okay. So this is equals to, you see that x bar minus mu over sigma over root n. That will be 26,343 minus 24,672. 24,672 divided by sigma is 3251 divided by root under 35, right? If you do that, you will get 3.04.04. This is what you will get if you use calculator. Okay. Now what do I want to do now is I want to use the critical value method here. So the alpha is given at 0.05, right? Isn't that true? Oh no, 0.01. So alpha is 0.01. So 0.01 and two tail, right? Meaning this alpha value should be divided into two tails. So you need to set both tails there. So what is the half of 0.01? 0.005, and this is also 0.005. We need to find out negative G alpha half and positive G alpha half. So how do we find out that is, so negative g alpha half is, you need to use inverse norm, 0.005 and then 0, 1. That will give 0, 1, okay? That will give you that value, okay? So how do I do that is, let me go to the calculator. Let me clear what I have. Second and then vars, go to the inverse norm. Okay, what is the area? 0.005, right? And then go down to the paste. So if you hit enter, you will get negative 2.58. So you got negative 2.58, okay? So this is negative 2.58. And then what is the other value? The other value will be positive 2.58 because that is g alpha half. You just take the negative sign off. So 2.58, this is negative 2.58. Now based on the critical value method, I want to write the decision. How to write the decision? You will check if that value falls in the shaded region or not, okay? What is the test value? Test value is 3.04. So 3.04 is bigger than 2.58, right? So the 3.04 may fall somewhere here. So it fall in the shaded region, meaning we reject the null hypothesis again. So since T falls in the shaded region, the critical region, so these values are called critical values and the shaded region is called critical region, okay? Critical region, we reject 80. So what is the conclusion? Then we reject means we reject the claim. So hence there are enough evidence to support the claim or the report, right? There are enough evidence. Oh, by the way, we reject there are not enough evidence. There are not enough evidence to support the claim or report that the average cost, let me go a little down, that the average cost is 24,671. So this is how we write the conclusion, okay? There are not enough evidence to support the claim. All right, or you can say there are enough evidence to support that the average is not equals to that, okay? You are supporting this, or you are not supporting, you are rejecting the claim, you are rejecting that. All right, so the next example will be the p-value method. Exactly the same problem, but the p-value method. If you look at that, see, so you find out the test value as 3.04. Now to find out the p-value for the two-tailed test, what you do is 2 times the area right of g, because this g falls in the right of that g falls in the right side, right? Because 0 is so 0 is in the middle, so 3 point something, right, fall somewhere here, 3.04. So you will be finding the area right of this. You will be finding that area. How do I find that area? And then multiply by 2, because it is the two-tailed test, okay? So 2 times normal CDF, 3 point that, and then 1 10 to the 10, whatever, you find out 0.002. This value is less than alpha, because alpha is 0.01. So p-value is 0.002. Hence we reject the null hypothesis. And then you write the conclusion. There are not enough evidence to support the claim that the average is 24,672. So you can do one more problem using the p-value method, but the next time I will show you how to use calculator to do all these examples, and then how do we do using how do you do the problem if the data is given. Okay guys, thank you.